All right, in this video, we're going to be talking about section 2.2, part 2. This is going to be a fairly short lesson. To start off, we're just going to make sure we're all still on the same page from part 1. So please pause the video and let's sketch this graph after you answer all of these questions. All right, so pause the video and I'll see you in a moment. All right, of all the questions that are most easy to answer here, degree of the function is not one of them. Leading coefficient's not terribly obvious. End behavior's not terribly obvious. Maximum number of turns, I don't even think we've talked about that, so we'll talk about that today. The y-intercept isn't obvious, so really all of these things are harder to find here than if it was not factored for us, except for the zeros. And the good news is finding the zeros is the most amount of work, so it's actually better for us that they have it in this form. So if we look at this problem, and I say each factor equal to 0, I'm going to get zeros at x equals, when is x squared minus 9 equal to 0? So let's go ahead and set them all equal to 0. So I've got that factor. Now keep in mind, that's different than me ignoring this 3. This 2x minus 1 happens 3 times. So I just need to know when is 2x minus 1 equal to 0, and I need to know when is x plus 1 equal to 0. Okay? But this is x, not x minus 9, the quantity squared. It's x squared minus 9 as one thing. All right, so this I'm going to factor, and I get x, or move the 9 over and take the square root. Either way, I'm going to get x equals positive or negative 3. I'm going to move the 1 and divide by 2. I get x equals a half. I'm going to subtract 1, and I get x equals negative 1. So I have 4 zeros. I have negative 1. Actually, I will do it in order from smallest to greatest. I have negative 3. I have negative 1. I have 1/2. And I have positive 3. I got 4 distinct zeros. The multiplicity of each one. All right. The x squared minus 9 led to x plus 3 and x minus 3, right, when I factored it. So those happen each one time. The 2x minus 1 happens 3 times. So that's the 1/2. That's 3 times. And the negative 1, that came from this one, and that happens 2 times. So I've got 3 odds. They pass through 3 times. And I have 1 even. All right, so let's remember that. Now let's put together some of the rest of this information. When I think about what does this polynomial look like if I were to write it out, f of x equals, what is the first term going to be is all I really care about. This one is going to give me an x squared. So I'm going to have something x squared. Here, I'm going to get a 2x times a 2x times a 2x and some other stuff. So that's going to be 8, 2 cubed, x cubed, right? The 2 is cubed and the x. Over here, I've got an x squared, and then I have a negative out front. So if I multiply all those things together, I'm going to have x to the 3, 4, 5, 6, 7. I have negative 8x to the 7th, and a bunch of other terms I don't care about. So unless I've made a mistake, 1, 2, 3, 4, 5, 6, 7. So the degree of the function is 7. The leading coefficient, I believe, is a negative 8. So that means the end behaviors are going to be as x goes to infinity, positive infinity, then y goes where? So this is degree of 7. So it's odd, but negative. So I'm going to flip it around. I'm going down. And as x goes to negative infinity, y is going up. So again, normally x to the 7th would look something like this, but I flipped it, so now it's going to look like this. The y-intercept usually is very obvious to find, right, because it's just the constant term, but here it's not so obvious, so I need to plug in 0 for x and find out. So I plug in 0 here, and I get 1 squared, I get 1. 0 here, I get negative 1 cubed, which is negative 1. So I have negative 1 times positive 1 is negative 1. 0 here gives me a negative 9. So I'm going to be down to positive 9, and then I think I'm now at negative 9 again. Okay, so all I'm doing is I'm plugging 0 in for all the x's and simplifying. So it'll be 1 times negative 1 times negative 9 times negative 1. Okay, let's see what we got. Zeros, negative 3. Negative 1. 1/2. And 3. I think my y-intercept, unless I made a mistake, is down here at negative 9. One of these is an even multiplicity. I'm just going to mark like a little E right here, so maybe I'll remember. Everything else is odd, and I know my end behavior. So I think my graph should look like this. I think I'm coming up, coming back down, coming up. Here, I'm supposedly bouncing. Then I've got to be back up at 0 for this. So I got to turn back down, and I'm passing through, ending up, which is what I said, right? So I said it should look like this, and it does. All right, I think that's it. Okay, so today we're going to do just one more little thing, and that is going to be working backwards. So here we have a situation on part A where we have a polynomial function where we don't know what it is, but we know it's zeros. So what we're going to do is we're going to work backwards. So let's kind of think about our general way we would do this. Like if this had been like a quadratic, we'd have our function, whatever it is, and we'd take it and we'd factor it out into however many factors we have, right? And then what do? I want to know when it equals 0. So I would take this factor. Let's pretend like this factor is x minus a, for example. So then I would take that factor and I would say, when is x minus a equal to 0? And I would add a to both sides, and I'd get x equals a. So that would be one of my zeros. Okay? So if I know one of my zeros, what do? Well, I make it so that it equals 0. So here I moved the a over. Let's move the a back. Right? So I'm going to move the a back, and I get x minus a is now one of my factors. So that's that factor. If I do the same thing for all the other zeros, I'm going to get all of the various factors. And then I can multiply them together, and I'll get my polynomial. All right, so let's go here and just write down what we know. I know that x equals negative 2 is a 0. I know that x equals positive 2 is a 0. And I know x equals 1 is a 0. So now let's see what they look like when they equal 0. So let's add 2 to both sides, and I get x plus 2 equals 0. I'm going to subtract 2. I get x minus 2 equals 0. I'm going to subtract 1. I get x minus 1 equals 0. What those are going to now be are these are all of the factors of the polynomial. So I know that this polynomial f of x has to include the factors of x plus 2, x minus 2, and x minus 1. And if I multiply that all out, I'm going to do the back 2 first. So I'm just going to write x plus 2 here. And then here I'm going to put the answer. I get x squared. I get negative x and negative 2x. That's negative 3x and plus 2. And then I'm going to multiply and distribute. I'm going to x cubed minus 3x squared plus 2x. Now I'm going to do the 2. I'm going to line it up so I get 2x squared minus 6x plus 4. I'm going to add those together, and I get my function is x cubed minus x squared minus 4x plus 4. Okay, so pretty straightforward. I'm going to take my zeros, right? And I'm saying x equals negative 2 is a 0. And now I'm going to move those over so it does say equals 0. There's your factor. Put all those factors together, and you've got your polynomial. Now, there is one thing I want to point out, and there's one important word in the question. And so if I ask you, what is the important word to help maybe clarify whether or not we found the right answer? There's one word in there out of 1, 2, 3, 4, 5, 6, 7, 8. And if I asked you to find out which one you started guessing, it would probably be the last one you'd guess. This letter, this number, I'm sorry, let's try that again. This word is one of the most important words here. Find a polynomial function. That seems to imply that there's not a single answer here, that there's multiple answers. So how could there be multiple answers to this question when really, I mean, this is the only way to do it? And the answer comes with factoring. And what if we factored out a constant, right? So at this stage right here, we've said that these are the three factors. But what if there was also just some random constant here, like a 3? That 3 is a constant wouldn't lead to another 0. It wouldn't change my zeros at all. But what it would do is it would change the stretch of this graph. And so there is a possible answer that's different depending on what we might choose for an a value. So you could stick like a -1 out front, you could stick a 7 out front, whatever. Obviously, we're just going to pick the one that's the most basic, where there's no a value. But just be aware that there could be lots of different answers to this question. Okay, now let's look at part B. So part B says, it shows us 2 zeros. But I want you to think for a minute about those 2 zeros. And I want you to think about this answer of 2 plus the square root of 11. So in order to get that answer, somebody had to take a square root, whether it was from the quadratic formula or whether it was from completing the square. Somebody did a square root somewhere and got this answer. But when we take a square root, we get a positive and a negative. So just because they told me the answer is 2 plus the square root of 11, actually there are 3 known zeros here. We know that x equals 3 is a 0, but I also know that x equals 2 plus or minus the square root of 11 are 2 more zeros. Because once again, quadratic formula, you'd get plus or minus. Completing the square, you'd get plus or minus. All right, so how is this going to change my approach? I would argue it's not going to change it at all. We're going to now make these both say equals 0. So I'm simply going to subtract the 3 over, and that gives me one of my factors is x minus 3 equals 0. So when I go to build my function, I know x minus 3 is one of my factors. But I also know that I led to these 2 zeros. So I'm going to do exactly the same thing. I need it to equal 0. So I'm going to move that 2 over. And I'm going to pause for a minute. Now, I could move the positive negative 11 over, but honestly, that square root is really annoying me. So what I want to do, let's get rid of that square root. So what shall we do? Let's square it. I'm going to square this side, and I'm going to square this side. And that's going to give me, let's do it right, x squared minus 4x plus 4 equals 11. Now let's make it say equals 0, and I've got x squared minus 4x minus 7 equals 0, and there is another factor. I'm going to move this down. So now I know f of x has to equal x minus 3 times x squared minus 4x minus 7. So let's think about this one more time. Had I factored it from what I'm about to find when I multiply to this, I said x minus 3 equal to 0, I solve, and I get x equals 3. There's my 0. This guy does not factor. There's nothing that multiplies to be 7 and subtracts to be 4. So I might have to use, say, completing the square. Right? So I take it, I set it equal to 0. I complete the square, which would end up here. This factors into this. I take the square root, which gives me positive negative 11, and I move that 2 over, and I got my zeros. So now we just need to finish it. X cubed minus 4x squared minus 7x negative 3x squared plus 12x and plus 21. So f of x, or one of the f of x's, could be others. Let's see, 5x and 21. And once again, we could multiply it by some a value and get multiple answers. But we're not going to worry about that. We're just going to give the best answer. All right, I hope this is all making sense, and I'm not sure anybody made it to the end of the video, but if you did, hey, thanks for lasting, and we'll see you in class.